NASA plans to build a full-scale base on the moon by the year 2033 as part of their new initiative called Artemis. It sounds like science fiction, especially when you remember one odd fact. The recent test flight to the moon was the first in a full 54 years. 54 years of complete silence. And now, suddenly, a full-scale colonization program is underway. Wait a minute, that's strange. We spent half a century stuck in low Earth orbit, and now, in just 10 years, we aim to build an entire city on another celestial body? Past bold promises to conquer the moon remained nothing but beautiful words on paper simply because the agency lacked clear, detailed plans. Things are different now. The urgency to act isn't driven by a sudden surge of scientific idealism. It's fueled by an impending clash between global powers on the moon. This has stopped being just a scientific mission. It's now a survival race. China has officially announced plans to land its astronauts on the lunar surface before 2030. Russia has its own ambitions to build a nuclear power station there. Suddenly, it's clear why the United States has scrambled into action. For 54 years, humanity largely ignored the moon. Now, nations are ready to pour massive budgets into reaching it within just a few years of each other. The stakes? Territory is rich with unique resources. Whoever establishes the first base will hold the cards and set the rules. One question remains: can the new American plan outpace China's lunar program, already locked in on the year 2030? Winning this race demanded a complete shakeup. The agency underwent major changes when Jarrett Isaacman took over as director. He openly admitted what many had suspected for years. For decades, the agency scattered its efforts, trying to please everyone, and ended up achieving almost nothing. Isaacman announced a tough new direction for the American space program under the codename Ignition. Unlike the space race of the 1960s, the goal now has shifted radically. It's no longer just about reaching the moon, planting a flag, and leaving. The mission is to actually settle there. But before landing on the moon, NASA plans to do something that seems almost counterintuitive. It will take a step back. The upcoming Artemis mission won't head to the moon. Instead, it will serve as a full dress rehearsal in Earth's orbit. And there's a very good reason for that. Yes, you heard that right. The next mission, Artemis 3, won't include a lunar landing. Instead, it will serve as a full-scale rehearsal in low Earth orbit. And this isn't a setback. In fact, it's probably the smartest move NASA has made in years. The old plan was too ambitious, a complex lunar landing immediately after a test flight, using unproven equipment. That was a recipe for disaster, not success. The new approach acknowledges a simple truth. Space doesn't forgive haste. So, until the year 2027, astronauts will train in a safe zone, just a few hundred miles above Earth. Testing in low Earth orbit lets them tackle problems safely and rescue the crew in emergencies. Unlike near the moon, where a trip home takes 3 days, and there's a lot to practice. Docking the Orion spacecraft with the landing module, moving inside to check life support systems, communications, and engines. For the first time, testing new lunar spacesuits in conditions as close to reality as possible. Meanwhile, Blue Origin is once again competing with its Blue Moonlander lander, directly challenging SpaceX in the race to build the landing module. NASA will test one or even both modules to pick the best one. The real return will only happen after this preparation. Mark the date. The Artemis 4 mission is scheduled for early 2028. This mission will be America's comeback to the moon, but not to the spots where Apollo astronauts once walked. Artemis 4 will land near the moon's south pole, a harsh world of impact craters and ancient mountain ranges. What makes this area unique is its valleys and craters bathed in eternal shadow. For billions of years, sunlight has never touched these places. Not a single ray. And scientists believe these dark pockets hold the moon's greatest treasure: water ice delivered by comets and asteroids. Water on the moon is more than just water. It provides oxygen to breathe and rocket fuel for future missions. It's the key to a permanent lunar base. So, the date is set, and the site is chosen. But one moon landing doesn't make a base. NASA's plan is much bigger. Starting in 2028, they intend to fly to the moon every 6 months. This isn't just a series of missions, it's a full-scale lunar assembly line. This lunar conveyor belt isn't driven by ambition. It answers a harsh necessity. The entire construction is planned to take 7 years and will cost $20 billion. The first phase is preparatory, guaranteeing constant access to the moon. To make this happen, 25 missions are scheduled within the first 3 years. Just think about that. 25 launches. 21 of those will include a landing on the surface. After the first touchdown of Artemis 4 in 2028, Americans will land on the moon nearly every 6 months. Here's what's striking. Out of all these missions, only 2 will have astronauts on board. The bulk, the toughest and most hazardous work, will be carried out by robots. But before sending an army of machines, they face a fundamental challenge, one that can destroy any piece of technology: the lunar night. It stretches for 2 full weeks. During that time, surface temperatures plunge below -200 degrees Celsius. This brutal cold freezes electronics, turns metal brittle like glass, and renders batteries useless. Solar panels? In this darkness, they're nothing but dead weight. Without a steady supply of heat and power, every rover, every lander, is doomed to become an icy statue. This isn't some hypothetical risk. It's a physical law that calls the entire concept of a permanent base into question. There's only one solution, and it's extreme: nuclear power. NASA plans to equip all its equipment with radioisotope thermal generators. Essentially, these are small nuclear batteries that generate heat and electricity from the natural decay of plutonium. They don't depend on sunlight and can operate for decades. It sounds intimidating, but this technology has long been proven. China has been running a lunar rover with a nuclear power source on the far side of the moon for several years. NASA has used the same setup on the Curiosity rover for over 10 years. But powering a single rover is one thing. Powering an entire construction site is a whole different challenge. For the moon, this technology will need to scale up to levels no one has tried before. This energy will power the cutting-edge fleet of robotic scouts. In the year 2027, the Viper rover will touch down on the moon, a true geological explorer the size of a golf cart, delivered by a Blue Origin landing module. Its mission: to create a detailed map of the South Pole's resources, uncovering deposits of water ice, hydrogen, oxygen, and rare earth metals. Supporting it, a pair of Moon Ranger rocket drones will leap across the surface, covering up to 50 kilometers at a time, exploring the most treacherous craters. Alongside them, 2 all-terrain vehicles with a range of 900 kilometers will begin the first groundwork, leveling the terrain for future missions. To control this entire fleet, a satellite network will be deployed around the moon. It will provide communication and data transfer at speeds up to 500 megabits per second from anywhere on the surface. This won't just let us operate the robots, it will let us see through their eyes. NASA has officially mandated that every piece of equipment, from drones to rovers, must have cameras for live streaming missions back to Earth. We'll watch in real time as robotic geologists search for water and prepare the landing ground for humans. Reconnaissance is just the beginning. Once the resource map is complete, heavy machinery will arrive on the moon. The second phase will start shifting from exploration to full-scale construction. And alongside the excavators, the first apartment on wheels will land on the lunar surface. The blueprint is ready. Construction begins. The second phase of the Artemis program, running from 2029 to 2032, will turn the moon's surface into a massive construction site. The scale is staggering. 27 launches and 24 landings are planned during this period. Forget about small research rovers. 6 new rovers are headed to the moon, designed for excavation and digging trenches for cables and pipelines. Real heavy machinery. But the star of this phase isn't an excavator. One of these new all-terrain vehicles will become the first sealed mobile living module, essentially an apartment on wheels. It weighs 15 tons and was developed by the Japanese Space Agency in partnership with Toyota. Inside, astronauts will be able to shed their spacesuits, wear regular clothes, and explore the surroundings for weeks, traveling far from the base. It's built to last a decade and can operate even during the pitch-black lunar night. Powering this entire construction will demand serious energy. Solar panels perched on tall masts will work alongside nuclear reactors. These aren't just small batteries for rovers. These are full-fledged mini power plants, generating hundreds of watts to supply multiple facilities at once. All this colossal effort serves one purpose. The third phase will run from 2033 through 2036. It aims to establish a permanent human presence on the lunar base. What once sounded like science fiction is becoming reality. A rotating crew of 4 astronauts will stay on the base for 28 days per mission. They'll live in several connected modules, essentially a lunar version of the International Space Station, but resting on solid ground. The base will have its own nuclear generator and receive monthly shipments of 8,000 kilograms of food, water, and air from Earth. Hauling 8 tons of cargo from Earth every month costs an incredible amount. That's where NASA's plan takes a surprising turn. NASA will start tapping into local resources, what experts call in situ resource utilization. Instead of shipping water from Earth, they'll extract it right on the Moon, from ice trapped in permanently shadowed craters. Then comes simple chemistry, the kind we all learned in school. They'll split that water into oxygen for breathing and hydrogen for rocket fuel. Suddenly, the Moon transforms from lifeless rock into a refueling station. Water is just the beginning. But what about building structures? Hauling every single brick from Earth? That's not going to work. NASA plans to experiment with 3-dimensional printing using lunar dust itself, called regolith, as raw material. They can turn it into liquid cement or bake it into sturdy building blocks. The idea of building with lunar dust isn't just theory. While NASA is still planning its 3-dimensional printing experiments, their biggest rival in the moon race has already moved forward. China has sent samples of the very first lunar bricks in history to its space station. China is already taking action. It has begun testing its own lunar bricks, aiming to build an egg-shaped structure called the lunar vessel. In 2024, Chinese scientists produced bricks from 5 different types of simulated lunar soil and tested 3 firing methods. Then in November of that year, they sent these samples to the Tiangong space station. But here's the most fascinating part, where the bricks are now. Not inside the station, where conditions are comfortable and controlled. Outside. These bricks will spend 3 years exposed to the vacuum of space, harsh radiation, and extreme temperature swings. You can't design a tougher test than that. China is putting its building materials to the ultimate challenge. Not in a model or simulator, but directly outside the orbital station's hull. Against this backdrop, NASA drops a surprising admission. They openly say the mission they're trying to accomplish is nearly impossible. This isn't pessimism, it's an honest assessment of the scale involved. Building a city on another celestial body pushes beyond everything humanity has ever done. But maybe that's the point. Humanity has always chased great achievements not despite their difficulty, but because of it. The moon has once again become a geopolitical stage. A battleground where superpowers will strive to achieve the impossible. This is a challenge thrown down to our generation. And the most incredible part? We get to watch the story of lunar colonization unfold live.